Welcome to Hot Topics. In this video, we're going to review the new table 430.52C1. Of course, this table used to be 430.52. It's just been renumbered and revised. One of the most important things in this revision to me is the squirrel cage induction type motor that's a NEMA B high efficiency motor, and then the NEMA B premium high efficiency motor. Now these motors have been identified now as IE1, IE2, IE3, and IE4 for easier identification. We used to just look at the IE1 started about 8.5, and IE2 would start at about, say, 10 times. IE3 would be about 12 times, and the IE4, which is a premium type motor today, would start at about 15 times the full load current rating of the motor. Now, full load current ratings of the motors is taken from table 430.250 based upon the horsepower and based upon the voltage and it being three-phase or single-phase type motor. But now notice also in the notes they refer you to 430.54, which these percentages may vary a little bit because if you look at 430.54, I also like to tie that same section with 430.7D as in dog, and it's basically multiple conductor motors, that you would have on a feeder or on a service. And sometimes, you'd have multiple conductor motors at plus other loads. So they give you some variation based upon this type of installation. So in your leisure time, I would recommend that you review 430.54 as well as 430.7D if you just wanted to learn more about this type of installation. You might not even be performing this type of installation, but it'd be good for you to just have that knowledge, And notice all the notes have been revised a little bit. So to stay in tune with the revisions that take place in this renumbered table 430.52C1 from the existing table 430.52. Now, looking at these motors that are high efficiency, then we want to take a look at our second illustration. We just looked at our illustration 1. Now let's take a look at a kind of, say, NEMA B high efficiency motor. Starting with the information that's in the callouts, let's start to the left, top hand side of the illustration. And a high efficiency fan blade is provided that causes the motor to run a lot cooler than regular induction motors. And of course the sandwich steel reduces the eddy current clutches, or current, excuse me. And then of course you have a better steel and a lot more steel in the motor that reduces the magnetic losses. You have a lot more copper in a high efficiency motor, and the better the motor is, like the premium, you're going to have a lot of copper and a lot of steel, and it reduces the I square R losses. That's better pronunciation, I think. And then of course you have the rotor bars and rings are bigger and reduces motor losses. Now, that are some of the basics. We could talk about these motors. God, I could just go endlessly almost talking about them. Someday maybe we'll go ahead and do a presentation and video just on these high efficiency motors because they're really mentioned big time in the 2023 edition of the NEC that naturally we will be looking at shortly in more detail. Right now I'm just calling out certain things that we might want to review. Now the next thing we want to look at is the section itself, 430.52C. And we're going to look at instantaneous circuit breaker settings. And notice all this has been revised. And when you look at 430.52C3, and that deals with the instantaneous trip circuit breaker, and then it gets into the application, tells you, it needs to be on a listed combination motor controller, or maybe in an MCC where you would have such a motor type starter. And then, of course, you have the exception number 1, that talks about the instantaneous trip circuit breaker and dealing with motor circuit protectors, MCPS abbreviated. And then the informational note 2 in the look at the illustration. And for the purpose of the article, instantaneous trip circuit breakers could include a dampening means to accommodate transit motor inrush current without nuisance tripping of the circuit breaker. See, and that's a good feature. And then, of course, we get into B part now. We just looked at 450.32C3A and informational notes 1 and 2. And now we're going to look at B, little b, which is titled setting. Instantaneous trip circuit breakers, as it reads, shall be adjusted to a setting in accordance with one of the following. Now see, this is all new numbering here and revised in such a manner to be more clarity added to it and easy to read and maybe understand what the code's asking us to do a little bit more in detail. Now, the B1 setting, no greater than the value in table 430.52C1. You can't exceed that if you can start your motor. Now, instead of exception, see, you're just dealing with B1 and then B2 where the value specified in our table 430.52C1 is not sufficient for the starting current of the motor. One of the following settings shall be permitted. Now, remember, when you go to Article 9, it shall be permitted. You have a choice. Does it need to be done? So you have a choice. But notice it breaks it down now into A. And notice motors other than Design B, energy efficient, and Design B, primary efficiency motors, shall be permitted to be increased, but shall in no case exceed 1,300%. So that means this would be a round down type size from that 1,300%. And then notice B, dealing with this energy efficient and Design B premium efficiency motor, shall be permitted to be increased, but again, it shall in no case exceed 1,700%. And see, that usually takes care of that 1,500% starting current due to the resistance of these high efficiency motors, and that setting will allow it to start and run because you're not going above it, see. And then where an engineering analysis, now notice here, they're allowing the engineer now to make an analysis, and the value is not sufficient for starting the motor, it shall not be necessary first to supply the values in table 430.52C1. Now notice how that revision and renumbering takes place. And then, of course, they refer you to NEMA 1, motors and generators, to obtain more information. And these high-efficiency motors, you'd find them in part 12.59. And you can find a lot more information pertaining to these energy type efficient motors. And in 3 here, it says where the motor full load current is 8 amps or less, the setting of the instantaneous trip circuit breaker with a continuous current rating of 15 amps or less in a listed combination motor controller that provides coordination for branch circuit overload, taking care of the overload, and short circuit and ground fault should be permitted to be increased to the values marked on the motor controller. So there, see, you're taking care of overload conditions, short circuit conditions, ground fault condition, all those items that we would have there. And so mainly this renumbered section has been revised to set requirements for the setting of an instantaneous trip circuit breaker when your motor is a NEMA B high efficiency or a NEMA B premium high efficiency motor, and it's in accordance with the settings that would be needed to allow these motors to start and run when you select a IE1, IE2, IE3, or IE4, which is usually, considered the premium NEMA B high efficiency motor. My name is James Gray Stallcup, and as I said before, you kind of have it, and we're just kind of going over some of these revisions and changes in the 2023 NEC that may be helpful to you, and kind of sound the alarm to look out for this if you're making these type of installations where a NEMA B high efficiency type motor is involved. So thank you for watching this video, and if you like our videos, we'll be sending more of them to you. Just hit that subscribe button and they'll come right to you, and you don't have to go looking for them. Have a good day, and thank you again for watching the video.